first part says compute p of x using the binomial probability formula. Then determine whether the normal distribution can be used to estimate this probability. If so, approximate p of x using the normal distribution and compare the result with the exact probability. Okay, so they're telling us n is 55. And I guess I don't have my tablet. Okay. We got n is equal to 55. We got p is equal to 0.3. And x is equal to 12. Okay, and find the probability of p of x. So we're trying to find the probability, since x is 12, that x is equal to 12. This is from section 6.2. So let me come back to here. I'm not going to use the formula, of course. I'm going to use a calculator. And we have our steps here. Identify the number of trials in. They gave that to us. Identify the probability of a single trial, little p. P is 0.3. List the x values the problem entails and rewrite with inequality equality symbols. Well, they just told us x equals 12, so that is given directly. And if I rewrote it with equality symbol, in this case, it would be x equals 12. It then says, use a table on the following slide to determine how to enter the function. Well, if I come over here, there's 4 possibilities. It can be equal, less than equal to, greater than equal to, or between a and b, including. Obviously, this is x equals. So the a that you see in this form right here is going to be the 12. So this is a. So from our formula, it says we're going to do Binomcdf in PA. So we're going to have Binomcdf in PA. Okay, so we'll have Binomcdf. N was 55. P is 0.3. That should be an A there, and A was 12. Okay, so let's plug that in the calculator, see what we get. So do second vars. I'll do an up arrow, probably the fastest way to get to it. And I'll choose Binomcdf. 55, comma, 0.3, comma, 12. Enter. I'm assuming 4 decimal places. I'll probably go read instructions and it'll say something different, but 0509. Round to 4 to 0509. That's how they get that. Okay. And this part you got, you just need to check whether n times p times 1 minus p is greater than or equal to 10. So let's use the normal distribution to approximate this. This is section 7.4. And let me see. There it is. Okay, this is going to be our form. We're going to do normal CDF, lower bound, upper bound, n times p, and then the square root of n times p times 1 minus p. But we have to do our 0.5 correction. So let's talk about that. Okay, so we got probability that x is equal to 12. Now we're going to either add or subtract 0.5. Here's 12. And the guideline always given in the classroom is that if your wording includes the number, then your shading has to include the number. And this is the oddball one. For this one, we have to subtract 0.5. And we have to add 0.5. It's always 0.5 for the correction. And this is when you got the equals case like that. So we'll do normal CDF. And our form, just to remind you, is low, high, the mean, which was n times p, and then comma, the square root of n times p times 1 minus p. Okay, so we'll do normal CDF. Low was 11.5, and we're looking at the shading area. Shaded area, shading. And high is 12.5. N was 55 times 12. or times p, 0.3, comma, square root in, which is 55. Little tablet's got a little place right there. Times p, which is 0.3, times 1 minus 0.3. So let's see what that gives us. There we go. Second vars, choose Normalcdf, 11.5, comma, 12.5, comma, 55 times 0.3, comma, square roots, we'll do second x squared, 55 times 0.3, and I'll put a beginning parentheses 1 minus 0.3. And then press enter. And we get 0.0490. Now this may not match my math lab exactly. If you do it by hand or via technology, then it's slightly off. You see how they say it's 0.0482, but we said 0.0490. But then they got some tolerance on these. And you see the correct answers when I put my mouse over there. One of them is 0.0490, which is what we came up with here. This is the technology answer. It's different if you did it by hand. Okay, now we said up above here that if your wording includes the number, your shading has to include the number, which it did here. Let's talk about that a little bit more, because that's sometimes the area where people have trouble. Let's look at some examples. More than 10. Okay. More than 10. Well, I'm going to, here's 10. In this case, I'm going to add 0.5. More than is shaded to the right. Because more than does not include 10. So my shading cannot include 10. If I had subtracted 0.5, this would have been 9.5. If I had shaded to the right, my shading would have included 10. And more than 10 does not include 10. So again, if your wording does not include 10, your shading cannot include 10. That should be a whole driver on whether you add or you subtract 0.5. Let's say at least 20. Stupid tablet. There you go, 20. Okay, at least 20. At least means shade to the right. And at least 20 includes 20, which in this case then I want to subtract 0.5. There we go. Okay. If your wording includes 20, your shading should include 20. One more. At most 30. Well, at most is shaded to the left, because it could be 1, 2, 3, all the way up. At most 30 includes 30. So here I'm going to need to add 0.5, because I'm shading to the left. And again, if your wording includes 30, then your shading has to include 30. So again, that should be a whole driver on whether you add or subtract 0.5.